Hey, 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 hey. Right. Let's get down to it. So, I thought I was going to talk a little bit about what I think is it's probably not in the public eye, especially for new programmers, but I think that there is well, let's just say that I think it's probably the most important thing we have in IT. And drum roll, what is that? It's data. Data. Let's talk about data and data structures and databases and all that good stuff. Now, why am I so excited about data? Well, I'm excited about data because I don't know if you ever thought about this at a conscious level, but everything you see around you, most likely, unless you're watching this from like literally outside, like in the middle of nowhere in like a vast forest or something, and I'm pretty sure, even though you're doing that, something around you is in a database. So almost every product you see around you, everything, like every street sign, every single all of this, all the companies that produce these goods and services document these things in some type of database. Now, in essence, for those of you who aren't so familiar with databases, a database is a computer program that will store information for you, long-term storage. Because, like, for a brief introduction to computers, you have, like, when your computer runs, it's going to use like the random access memory, or that memory in essence, to do computations and all that stuff. But when you turn that off, it's your hard drive where you're storing, like long-term storing, all the information that you save. So if you're a computer game fan like myself and you play a lot of computer games, your save files are on your hard drive. And that's what the database does. The database is responsible for making sure that your data is consistent and that it's, in a format that makes it easy for you to access it and change it and all that good stuff. Now, on to more concrete things. The idea basically is that we live in, or my idea is that you and I, we both live in what we call the information age. And the information age could not exist without data. That's the whole thing. Like, if you think about it, like all the things that you're ever going to build, most likely with a computer, or like if you're a programmer and so forth, anything you build will be connected to providing some type of information value to the person who's consuming your application. There are very few applications that are in no way connected to a storage system or like a data structure or something like that. I would argue that it's almost, I can't even think of something that's non-trivial that doesn't have some type of storage or data structure. So, why is this important to you? Well, this is important to you because the data layer, like in general, you have a few layers, conceptual layers in your application. You have the data layer, which is at the bottom, and then you have your application or service layer, like the business logic, which is at the middle, and then at the top you have the view layer, where, like, if you have such a thing. But it's usually the case that you have a view of some sort, which is like the UI and that stuff. So, the reason why the data layer is so important, and I argue it's the most important layer, is because without the data and the information that you need to display to the user or do your computations, then there will be no point to your application, most likely. That's the reason people go to Facebook, is because they have information, and that data is stored in a database in a data schema. So, data schemas, what's a data schema? A data schema is the format that you store your information. So let's say that you have a user, and that user has some information associated with it, like a name, a last name, an email address, and all that stuff. Now we store that information like in a compound way so that we can easily access all the information about a single user by having some type of ID or something like that. Now, why is this, and I argue this is probably the most important thing to get really, really right in your application. Why is it so important? Well, it is important because at the bottom level, and the way that you're accessing your data and the way that you're storing your data, that is the thing that will affect the behavior of your application the most. If you have a really good data schema, so that whenever you need to get some data and send it to the user and like create a page, that's going to positively affect your performance. But if you have like the performance load times and all that stuff, you know, if that's what everybody's talking about in this industry, performance and first meaningful paint on the web and all that good stuff. That's very much depending on the data. It's a bottleneck. That's the biggest bottleneck you have. If you don't have an effective way of getting data to the user, if that pipeline is slow, it slows down your entire application because it's all starting at the database level. So it's really important that is effective. So if you have a bad data structure, and let's say that you have a relational database and you do a lot of joins and like a query is really slow moving, then you're pretty much fucked. There's not much, like you can, of course there are things you can do, but you cannot just magically write some code and make your code, like you can't use code to make that a little bit more effective in general. It's, you're gonna have to do make a bigger investment, and it's going to cascade through your entire application for the most part. Because I mean, if your code, as I said, it's all starting with your data. So for the most part, you're gonna have to rewrite quite a bit of your application to make it work, unless you know, like if you have a really clever architect and all that good stuff, you may save yourself a little bit of hassle. But as I said, if you have a bad data schema and you don't think about these things properly, then you can be in the type of situation which is what Ticketmaster is in. So you have a system that was designed for a long time ago, and the data schema and the structure of the data layer is managed by an entirely like I don't work on the database level, none of my colleagues do. We have access to that data, but there's an entire group of people who are dedicated to just managing the tickets and doing all that stuff. And the problem is that the way that they thought about how to structure their API, which is where we're getting our data, is wrong. It's wrong. It's not effective at all. And because the system is so large and it's so inflexible, we suffer. Like the website suffers because they have enforced certain rules and structures and so forth that like dictates for us how we are accessing the data that we need. That means that, as I said, it cascades upwards. It just flows. It creates rings. So if their system sucks, our system will suck, for the most part. Like there are certain things that we have to make things work in a certain way, because that's the way that the API and the data layer is designed to work. And there's very little we can do about it. I'll give you a concrete example. One of the first things I asked when I started was, because I'm a user experience type of guy, I asked, why are we not showing a number that illustrates to the user how many tickets are still available? It seems to me to be a reasonable thing. Or if I want to buy some tickets and I want to see how many tickets are there, and that would be a good number. And they basically said, well, we can't, because the data, we don't have that data and we can't get it in any way. Do you see what I'm saying? Because this is not stored in a database, it's not accessible to us in any way. We simply lack something in a feature that would be very useful to our users. And it's not because they don't have that information, it's because the way that their data layer works doesn't allow them to effectively provide that number. So that's a very big reason why data structures are important. And there are solutions to solving this problem, because over time you'll figure out that your data structure changes and sometimes it gets really complicated. There is a really nice initiative by Facebook which is called GraphQL, and now more recently it's becoming Relay, which is trying to solve this problem where you have different data structures and different databases, and basically figuring out how to dynamically allow you to have any formatting on your data schema, allowing the client to dictate that, hey, I need all of this data. Can you please provide a payload of exactly this data structure and send it to me? Because right now we use either RPC or like RESTful APIs. And the problem with these things is like for this on the server side, that's that's a fairly effective way of dealing with things because, well, I'll let you look into it, but it's a fairly effective system. Problem is that it's not so performant on the client side. You have to do multiple requests to get all the data that you need, and sometimes you get more data than you want, and it's not that performant in comparison. And what's happening with GraphQL, which is really great, is that you can send a single request from the client with basically with a special syntax that says, hey, I need this data and I need it in this format. Server, can you please build this for me and send that back to me? Because what happens is then that you can get a single request to get the exact amount of data that you're looking for, and that's pretty cool. Like I explained it to my girlfriend in this way, because I was really excited when this came out. I said, imagine that somebody built a button that you could put on any car, and as soon as you pressed that button, that car would consume like 20% less fuel and run 20% faster. That's how big this is. That's how massive this idea is, and it's just genius. It's not perfect for every use case. You shouldn't use it for like a small little application with a single server and a single client. Don't do that. But if you have an application where you have multiple data sources, maybe you're talking to several different databases, then this makes a lot of sense. It's a really good solution to solve that type of problem. Because trust me, guys, you cannot invest enough time in figuring out how to have a really effective data structure, because, as I said earlier, it is the thing that will dictate how everything else works in your system.